Imagine a star like our Sun, shining brightly for billions of years. What happens when it runs out of fuel? It transforms into a white dwarf, a stellar remnant that is both fascinating and mysterious. Today, we're going to explore the intriguing life and times of these cosmic wonders. White dwarfs are born from stars that have exhausted their nuclear fuel. When a star like our Sun reaches the end of its life, it undergoes a dramatic transformation. After burning hydrogen into helium for billions of years, the core becomes a hot, dense ball of carbon and oxygen. The outer layers are ejected into space, forming a beautiful planetary nebula, leaving behind the core, which becomes a white dwarf. One of the most astonishing features of white dwarfs is their incredible density. Imagine compressing a mass similar to that of the Sun into a volume roughly the size of Earth. This means that a mere teaspoon of white dwarf material would weigh as much as an elephant on Earth. This density is due to the force of gravity squeezing the star's matter into a small volume held up by a quantum mechanical phenomenon known as electron degeneracy pressure. White dwarfs are like cosmic clocks, gradually cooling and fading over billions of years. They no longer undergo nuclear fusion, so they slowly radiate away their heat. Eventually, they will become cold, dark black dwarfs, but this process takes longer than the current age of the universe, so none exist yet. In binary star systems, white dwarfs can become stellar cannibals. If a white dwarf is close enough to a companion star, it can pull material from its partner, accumulating mass on its surface. If it gains enough mass, it can trigger a runaway nuclear reaction, leading to a spectacular Type Ia supernova explosion. These explosions are so bright that they can outshine entire galaxies for a short time and are crucial for measuring cosmic distances. Our very own Sun is destined to become a white dwarf. In about 5 billion years, after expanding into a red giant and shedding its outer layers, the Sun will leave behind a white dwarf core. This transformation is a natural part of the life cycle of stars, and it's a fate shared by 97% of the stars in our galaxy. White dwarfs are like cosmic archaeologists, preserving clues about their past. Some white dwarfs show signs of rocky debris in their atmospheres, hinting at the presence of planets that once orbited them. These remnants might have been sites of life before the star's transformation, offering tantalizing hints about the potential for life elsewhere in the universe. As the universe continues to age, white dwarfs will play a crucial role in its evolution. Over trillions of years, they will cool and fade, but their presence will continue to shape the dynamics of galaxies. They are the silent witnesses to the history of the cosmos, holding secrets about the formation and evolution of stars.